Good morning all. In today's topic, let us discuss about time energy uncertainty principle. Right? Now, consider a case of free particle. Okay? Let the rest mass of particle is m0. Let us think that it is moving in positive x direction with velocity Vx. Then what we will write? Kinetic energy, that is nothing but half m0 Vx square, or half m0 square Vx square by m0, or half m0 Vx whole square by m0. What is mass into velocity? Momentum. So px square by m0, where m0 Vx is nothing but px, which is nothing but linear momentum. Okay. So this is kinetic energy. Now let delta px is the uncertainty in momentum. Okay. Now delta E be the uncertainty in energy. Then differentiating equation 1, we get delta E equal to what it becomes? 2 px delta px by 2, sorry, here 2 will be there, 2 m0. Okay, 2 m0, or we can write 2 strikes off. Okay, so now we can write it as px delta px is equal to cross multiplication m0 delta E, or delta px is equal to m0 by px delta E. But what is px? m0 Vx delta E, right? So now delta px becomes 1 by Vx, m0 strikes off delta E. Put it as equation 1. Okay. Now further, let the uncertainty in time interval, this is uncertainty, delta t is the uncertainty produced in time interval for measurement at point x. Then uncertainty delta x, let delta x be the uncertainty in position of a particle. Then what we will write? Delta x is nothing but Vx delta t. Okay, so Vx is equal to, from this formula, delta x by delta t, change in position by time interval, that we call velocity. From that equation only we wrote. Okay, so now put it as equation 2, right? So now let us multiply both equations. What happens? Delta px delta x is equal to 1 by Vx delta E into Vx delta t. Vx strikes off. So now what we got? Delta x delta px is equal to delta t into delta E, right? But according to Heisenberg uncertainty principle, delta x delta px is greater than or equal to h by 4 pi. As this is greater than or equal to h by 4 pi, then automatically delta t delta E is greater than or equal to h by 4 pi. So this is time energy uncertainty principle, right? Now let us see here, according to Bohr's orbit concept, what Bohr is saying, according to Bohr's orbit concept, an electron revolves in one of the quantized orbits, right? Each orbit has a sharply defined energy. We know that electrons revolve in quantized orbits, and each quantized orbit has its own energy, a defined energy, and there will be no uncertainty produced in such energies. There will be no uncertainties. So as there is no uncertainty, then delta E becomes 0, no? When delta E becomes 0, then delta T, what it happens? It becomes infinite. When delta E becomes 0, then delta T becomes infinite. So infinite means it shows that the energy states of atom must have infinite lifetime. The energy state of atom must have infinite lifetime. But we know that the excited states of atom from which the radiation occur has a lifetime of order 10 to the power of 8 seconds. Okay. So here we know that the excited states from which the radiation occurs have a lifetime of 10 to the power of minus 8 seconds only. But here we are saying that as there is no uncertainty in the energy of a particular orbit, delta E becomes 0 and delta T becomes infinite. So as that this concept, the energy states must have infinite lifetime, but energy states have only 10 to the power of minus 8 second lifetime, not infinite. So from this we can say that the concept of Bohr's orbit violates uncertainty principle. Okay, the concept of Bohr's orbit violates uncertainty principle. So this is about how the Bohr's orbit violates the uncertainty principle. Thank you.